Now that we've learned several different ways of factoring polynomials, we'd like to learn how to apply this to be able to solve polynomial equations. Now, solving polynomial equations is based on something called the zero factor property, which says that if you have a product, meaning a multiplication, of an a times a b, and that's equal to 0, then either a has to be equal to 0 or b has to be equal to 0. And the way we use that to solve polynomial equations is first we'll get a 0 on one side of the equation, and then we'll factor the other side of the equation so that it's a product, a times b, and then we can set each factor or each part of the factoring problem equal to 0 and solve them separately. Now this process is often called the factoring method because you use factoring to solve the equation. So we'll start by getting 0 on one side of the equation, and that can be done by just adding or subtracting something from both sides of the equation if necessary. Then we'll factor the non-zero side of the equation. By factoring it, we're really writing it as a multiplication problem, so it fits this form a times b equals 0. And then we'll set each factor equal to 0 and solve each equation separately. So we're really just using this zero factor property because by setting each factor equal to 0, we're really setting the a equal to 0 or the b equal to 0, and we're solving them separately. Now this method can be used to solve quadratic equations, and those are equations where the highest power of x is 2, or cubic equations where the highest power of x is 3, or fourth degree equations where the highest power of x is 4, etc. It really can be used on any polynomial equation, so you just use the same technique. Let's start by applying this process to a quadratic equation. Now the reason why this is a quadratic equation is because the highest power of x, right here, is power of 2. And that's what quadratic means. It means the highest power of x is 2. And this process will work in many cases to solve those kinds of equations. Now, what are the steps? First, get 0 on one side of the equation. So to get 0 on one side, we'll have to subtract 28 from both sides of the equation. And that will bring down an equal 0 here. And on the left side, we'll have x squared plus 3x minus 28. Now we want to try to factor the left side. Now it's a trinomial, so we'll use the techniques we know for trinomials. And notice that the coefficient in front of the x squared is a 1, so that's the simpler kind of trinomial. That's the kind of trinomial where we really should just be able to write our FOIL problem down immediately. And we'll put an x in the front of each one, and then we need to find two numbers that multiply out to equal negative 28, and those same two numbers have to add up to a positive 3. So it would be a positive 7 and a negative 4. So put them in that way with a plus 7 and a minus 4. And now once we've factored it, now we're going to set each factor equal to 0. So we'll have x plus 7 equals 0, and then x minus 4 equals 0. So we get two separate equations, and we just solve them separately. For this one, we just subtract 7 from both sides, so x is negative 7. And on this side, we'll add 4 to both sides, so x equals 4. And notice we get two different solutions. That's not unusual for a quadratic equation. We often will get two solutions to a quadratic equation. If you check them, you'll see they both work, because when you put the negative 7 in for x, you get 49 minus 21 equals 28, which is true. And when you put the 4 in for x, you get 16 plus 12 equals 28, which is also true. So both of them are valid solutions. Okay, now let's try another example. Now in this example, we already have equals 0 on one side, so the first step is done for us. So we can go right to the second step where we're going to factor this other side. Now this is a trinomial also. There's 3 terms there, but this is the more difficult type because there's a coefficient of 4 in front of that p squared. So this is the kind where we're going to have to take 4 times negative 10, which is negative 40, and find 2 numbers that multiply out to equal negative 40 and that add up to equal a negative 3. And it's going to be a negative 8 and a positive 5. And then we use those to split the middle term. So we'd have 4p squared minus 8p plus 5p minus 10 equals 0. Then we group the first 2 and the last 2. And we'll take the GCF out of the first 2. Now between these first 2 terms, the GCF would be 4p. So we'll factor out 4p from those, which gives us p minus 2. Then you have to leave a little blank space and copy down the p minus 2 again over here. And then ask yourself, what would you multiply in front of that second set of parentheses? So when you distributed it through, you would end up with a positive 5p minus 10. And it's plus 5. So it's plus 5. Carry down the equals 0. And then to finish factoring this, it ends up being p minus 2 times 4p plus 5. And then we'll have to set each part of that equal to 0. So we have p minus 2 equals 0. And that will give us p equals 2 for one solution. And then we have 4p plus 5 equals 0. So 4p equals negative 5. And p would be negative 5 fourths for the second solution. Now in this next example, it almost looks like the left side is already factored, but it's really of no help to us because we don't have a 0 on the other side of the equation. And it's only useful to have it factored when there's a 0 on the other side. So really what you'd have to do here would be to FOIL this together, doing the first and then the outers and then the inners and the lasts. So that would give us, let's see, x squared minus 2x plus 3x minus 6 equals 24. And then when you combine your like terms together, that would be x squared plus x minus 6 equals 24. And then you'd have to get the 0 on the right side by subtracting 24 from both sides. That gives us x squared plus x minus 30 equals 0. Now we want to try to factor this trinomial. Now this is the simpler kind of trinomial because there's a 1 in front of that x squared. So in that case we can write the FOIL problem down immediately. We don't have to go through that whole grouping process. Put an x in the front of each one. All we need to do is find 2 numbers that multiply out to equal negative 30 and that add up to 1. And that would be a positive 6 and a negative 5. So put it in with a plus 6 and a minus 5. And then set each one equal to 0. So x plus 6 equals 0 and x minus 5 equals 0. And so on the left side we'll just subtract 6 from both sides. So x equals negative 6. And on the right side add 5 to both sides, so x equals 5. Now let's try to use the same process on a cubic equation. Now the reason I call this a cubic equation because the highest power of x is 3. So that's called a cubic equation. But really it's the same process. We want to start by getting a 0 on one side. And I'm going to get a 0 on the right side because I'd really like that x cubed to have a positive number. So if I added it to both sides, it would cancel off on the right side and it would end up being positive on the left side. And then I'm going to subtract the 24x squared from both sides. So let's just see what we have here. The equal sign should come straight down, more or less. And then we're going to have 4x cubed minus 24x squared plus 36x equals 0. Sorry, that kind of got crammed all together here because I was trying to squeeze that into the left side. But hopefully you can read it okay. And then that's a trinomial. Now, what's our general factoring strategy? We're always supposed to look for a GCF first, right? And this one has it. 4 goes into all three numbers evenly, and x is in every term. So the GCF would be 4x. So we definitely want to factor that out first. Let me spread this out a little here. And that gives us x squared minus 6x plus 9. Now we have a trinomial inside the parentheses. It's the simpler kind because the x squared just has a 1 in front of it. So we should be able to just bring the 4x down and write this out as a FOIL problem with an x in front of each one. We need to find two numbers that multiply out to 9 and add up to -6. And it's going to be a -3 and another -3. So it's going to be -3 and -3. So now we have to set each one equal to 0. Now the difference with a cubic equation is you actually have three different things here that you have to set equal to 0. So you're going to do the 4x equals 0, and then x minus 3 equals 0, and then another x minus 3 equals 0. Those last two are the same in this case, but that generally wouldn't happen. And when you solve these, this first one, divide both sides by 4. Now 0 divided by any other number is still 0, so your solution is 0 there. And here you add 3 to both sides, so x equals 3. And then this one's the same equation, so you're going to get the same answer. So there's really only two solutions in this particular problem. But you can see it's quite possible that a cubic equation could have three solutions because you could get three different answers to these three equations. Okay, here's another cubic equation. And again, we already have the 0 on one side, so that first step's done for us. So we just want to try to factor this left side. And remember, our general strategy is find a GCF if there is one and pull that out first. And 4 does go into both of these two numbers, and both things also have x. So 4x would be the GCF. So we'll pull that out, which gives us x squared minus 25. And then this is two terms, so that's a difference of two squares. So we can factor that down into x plus 5 times x minus 5. And now, so next we have to take all three of these factors and set them equal to 0. So we have 4x equals 0, and then x plus 5 equals 0, and then x minus 5 equals 0. And in this first case, you just divide by 4, and so x is 0. And then subtract 5 from both sides in the second one, so x equals -5. And then add 5 to both sides in the third one, so x equals 5. And you see this cubic equation has three different solutions. Now the factoring method can also be used to find x-intercepts of a polynomial function. For example, if we want to find the x-intercepts, remember our strategy was to plug a 0 in for y. And f of x is really the same as y. So you'd plug a 0 in for f of x, which would give you 0 equals 6x cubed plus 15x squared plus 6x. So that is a polynomial equation. And you've already got it equal to 0, so that step is done. So all you need to do is try to factor this other side of the equation. And again, always look for the GCF first. These are all divisible by 3, and they all have an x, so it would be 3x. So 0 equals 3x times, and then you would have a 2x squared plus 5x plus 2. Then we have to try to factor this trinomial. This trinomial is the harder case because you have a 2 in front of the x squared. So we'll use our procedure. So 2 times 2 is 4. And we need to find two numbers that multiply out to 4 and add up to 5. That's pretty easy. It's 4 and 1. And then we split that middle term into a 4x and a 1x. So we'd have 2x squared plus 4x plus 1x plus 2. And then we group the first two and the last two. We take out our GCF from the first two, which would just be 2x times x plus 2. We're going to copy down the x plus 2 over here. And then we're going to figure out what do we need to multiply by. So it multiplies out to equal plus x plus 2. It's already plus x plus 2, so it would you just multiply by 1, and it'd be a positive 1, so put it in with a plus 1. So the answer to that part of the factoring problem is x plus 2 times 2x plus 1. But let's not forget to bring down our GCF, which is 3x. And that's all equal to 0. So now we just set each part equal to 0. So we have 3x equals 0, and then x plus 2 equals 0, and then 2x plus 1 equals 0. And when you solve them out, you would just get x equals 0 for this first one, and then x equals negative 2 for the second one, because you'd subtract 2 from both sides. And then in this last one, you subtract 1 from both sides and then divide by 2. So you would actually end up with x equals negative 1/2. Now it's important to know that you can also solve polynomial equations graphically, as I've shown you before. That method works on all equations, in fact. But the factoring method that we've been practicing doesn't work on every single polynomial equation, because sometimes after you get a 0 on one side, you can't factor the other side, so it's non-factorable. In fact, this example is a case like that. So I want to show you how you could still solve this using your graphing calculator. So first of all, you have to enter in one side of the equation into y1, and then the other side of the equation into y2. So as you can see, I'm putting in x cubed minus 4x squared plus 5 into y1. And then the other side of the equation is x minus 5, and then I'm entering into y2. And then we'll need to graph those together. I'm just going to do a zoom 6, which is a standard zoom. And there's the first graph, and there's the second graph. And I'm looking now for the points of intersection. So I can do second, and then trace, and then number 5 for intersect. And for first curve, we just hit enter, and then second curve, enter again. And then for guess, I'm going to move it close to this first point of intersection on the far left here, and then hit enter, and that would be our first solution. Now the solution is the x value only, so it would be x equals, I'm going to round that off to negative 1.45. Okay, now I'm going to repeat this process for the other 2 points of intersection. So we'll do second trace again, and then intersect, or number 5, and then enter for first curve and enter for second curve. And now we'll move it over closer to this second point of intersection and hit enter again, and that gives us our next solution. So x equals 2. So we'll write that down, x equals 2. And then we have to do this one more time, so we'll do the second trace, intersect again, and then first curve enter, and second curve enter, and then for the guess, we'll move it over closer to this third point of intersection. Then hit enter again, and the x now is 3.45 if I round that off a little bit. 3.45. And those would be the three solutions for this particular equation. Now, quadratic functions can also be used to model certain situations. All the work that we've done with modeling so far has pretty much been with linear functions or straight lines, because the data that we've dealt with has pretty well followed straight lines. But sometimes when you look at a set of data in a scatter plot, the points curve a little bit. And in that case, a quadratic model might be better because the graph of a quadratic function is a parabola which curves a little bit. Now in this example, we're given the first quarter internet sales of goods and services for various different years. And you can see that between 2001 and 2005, the first quarter internet sales has gone up, indicating that people are shopping more online as time goes on. And what I'd like to do is make a scatter plot of this data on our graphing calculator. And notice that we're going to let t be the number of years since 2000. So I'm going to add in a column for t here. So 2001 would really be t equal 1 because that's 1 year since 2000. And then we'd have a 2 and a 3 and a 4 and a 5. And we'd like to enter those values into L1 in our calculator. As you can see, I have them over here. So take your graphing calculator and try that. Under L1, so you'd press Stat and then Edit. And then in L1, type in those numbers 1, 2, 3, 4, and 5 for your x's. And then put these values in here for your y's. So the 8.3 and the 9.8 and the 12.8 and the 16.0 and the 19.8. Now I'd like to make a scatter plot of this data. And in order to do that, I have to start by pressing second and then y equals, which is the stat plot, and then hit enter for plot 1. So we can set that up. And we want to turn it on. And for type, we want it set to a scatter plot of L1 and L2 with a certain mark. And then I'm also going to press y equals and clear these other equations out before I try to graph the scatter plot because I don't really want to see them. And then zoom, and 9 will make the calculator make a scatter plot for that. Now you can see that these points kind of curve upward a little bit. So we're going to try to use a quadratic model for that. And the quadratic model is given right here. So it's f of t equals 1/3 t squared plus t plus 6.5. So to graph that, we'll press y equals, and we'll go ahead and enter that equation in. I'll put the 1/3 inside parentheses. So it's 1/3 times x squared plus x plus 6.5. And then once we've got that entered in, we just hit the graph key. And we can see our calculator graphs that model along with the scatter plot. And you see that is a pretty good model because the curve comes very close to all the points that are in the scatter plot. So we've answered A. We've used the graphing calculator to draw a model and the scattergram in the same window. And does the model fit the data well? Well, yes, it does, because we can see from our picture that the model fits the data very well. So let's answer these other questions. Let's start with part B. Now part B says find the s-intercept. So to find the s-intercept, we have to substitute a 0 in for the opposite variable, which is t. So we're going to let t be 0. And when we plug in a t equals 0, that's really f of 0. We'd get 1/3 times 0 squared plus 0 plus 6.5. And that's just going to come out to be 6.5. So as an ordered pair, when t is 0, s, or the sales, is 6.5. And what that would mean in the context of this problem, now t equals 0 corresponds to the year 2000. So that means that in the year 2000, the first quarter internet sales was $6.5 billion. So the first quarter internet sales was 6.5, and remember they're measured in billions of dollars, so it would be $6.5 billion. Now part C asks us to predict the first quarter internet sales in 2015. So first of all, the year 2015 corresponds to a t value of 15 because it's 15 years after 2000. So we would just evaluate f of 15. We'd substitute a 15 in place of t in our equation. So we'd have 1/3 times t times 15 squared plus 15 plus 6.5. And I just plugged that into my calculator, and it came out to be 96.5. So it would be $96.5 billion. Now part D asks us to estimate in which year the first quarter internet sales were $24.5 billion. That means we're going to have to plug a 24.5 in on the left side of the equation because that's the sales. So our function is f of t, which represents the sales, equals 1/3 t squared plus t plus 6.5. And we're going to have to plug in a 24.5 in on the left side of the equation. And now to solve this, we'll use the technique we learned where you need to first get a 0 on one side of the equation. So we'll subtract 24.5 from both sides of our equation. And that gives us a 0 on the left. So we have 0 equals 1/3 t squared plus t minus 18. And I'd like to eliminate the fraction 1/3. So I'm going to multiply both sides of my equation by 3. So that means I multiply every single term by 3. So 0 times 3 is still 0. And 1/3 times 3 is 1, so that will just be 1t squared. And then t times 3 is 3t. And then 18 times 3 is 54. And that just eliminates the fraction from the problem. So now I have a 0 on one side, which is good. And so now I want to try to factor this other side. Now luckily that's a trinomial, and that's the simpler kind because there's just a coefficient of 1 in front of that t squared. So we should be able to write that FOIL problem down immediately. We just need to find two numbers that multiply out to equal -54 and then add up to 3. And the numbers there are a +9 and a -6. So it's going to be t plus 9 and t minus 6. And now we'll set both factors equal to 0. So t plus 9 equals 0 and t minus 6 equals 0. If we solve this one, we get t equals -9, and over here we get t equals 6. Now in this problem, time starts at 0, meaning year 2000, and goes forward. So a negative time value doesn't really make sense in this problem. So we're going to reject this solution because it doesn't really fit this problem. That's called an extraneous solution. The real answer that we want to keep is the t equals 6. And that means it's 6 years after the year 2000. So it would be 2006.